So this will be the solution to question 11 on the 116 exam 1 from the winter 21 quarter. And this question is moving into section 15.5, which looks at energy and intensity. So the intensity of a sound source or a light source is given by the power of the source divided by the area over which that the sort of energy of the wave is sort of spread over. So we've been only looking at spherical sound sources and spherical light sources, and particularly more looking at the sound source. So looking at the power of the source, then divided by sort of a spherical sound wave. So looking at the energy of that wave being spread over a sort of the area of a sphere, 4 pi r squared. So that's what this basic expression is sort of getting at, thinking about the intensity of a wave. So that's let's look at the context. So the context was sort of a mix of sort of qualitative and quantitative, and we can dig into a lot of detail on the quantitative if we know the sort of relationships of the sort of between the intensity and the sort of the area, both the area of the sphere plus the area of the ears, in this case the eardrums. But let's just work through it here. So we got a fireworks display. A particular firework is launched from the ground, and at a certain height it explodes. Explosion results in the emission of a spherical sound wave. So that's a key note there. The two so there's a bird picking up that sound, and there's also a student. So a sparrow, a small bird, and a student both hear the sound from the explosion. The sparrow is located 400 meters from the explosion, and the student is located 800 meters from the explosion. So I made, for both versions, I made the student be located twice the distance from the source than the sparrow. So I think the other version might have been 500 and 1000 meters. But the radius of the eardrum of the sparrow is half the size of that for the student. Assume both eardrums are circular. So there's sort of this, I'm sort of testing sort of relationship here between the sort of the intensity of a wave is sort of proportional to 1 over r squared, r representing the distance from the source, but then also that the area of these eardrums, since they're circular, also has an r squared dependence, and that's sort of the play here on those two ideas that's sort of been tested. The amount of energy due to the sound wave that passed through the sparrow's eardrum in 1 second, so energy per unit time is power. So really we're trying to compare the power of the wave that's passing through the sparrow's eardrum, compare that to the power of the wave passing through the student's eardrum. So let's just draw maybe a quick picture here. So let's say this is the firework. Okay, my attempt at drawing a small bird will be really bad. Hopefully you can forgive me for that. And a person. Now because we're going to be using, we've got two sort of distances here. We've got sort of two radii. We've got a radii for the explosion, how far they are away from the source, plus the radius of their eardrums. I will use different notation here. So I'm going to use large R for the radius from the source, and because one's a sparrow and one's a student and they're both S's, I'll use B for bird and P for person. So this is R of the bird and this is R of the person, and in both cases the large R of the person is twice the large R of the bird. Okay. Now the intensity is previously defined as the power of the source divided by 4 pi r squared. We know it's a spherical sound wave. Maybe I'll use a large R here to indicate that we're using it consistent with the R's that I've just shown you here. So we can see that the intensity falls off as a 1 over r squared function for a given power for the source. So we can use this sort of relationship, that inverse relationship of matching the intensity to the distance. So the I of the bird over the I of the person is equal to R of the bird squared divided by R. Sorry, I did it the wrong way around. Inverse, so the ratio of the intensity is the inverse ratio of the square of the distances from the source. So R of the bird squared. So the intensity of the person will then only be 1/4 the intensity that the bird experiences. So that's sort of the key relationship that I was trying to examine, is that we know that if we don't have to do any sort of calculations here on what's the power of the actual firework, do any 4 pi's, because they're twice the distance. A person that's located twice the distance from a sound, of a spherical sound wave, will only experience 1/4 of the intensity. So that's sort of that inverse relationship. So the ratio of the intensities is the inverse relationship between the square of the distances from the source. So that's one sort of key idea. And then let's talk a little bit about the area of the eardrums. So the small a in this case, the area of the ear, is going to be pi, and I'll use small r squared. But again, what we're doing here is that the r of the person is twice the r of the bird for the eardrum. Let's give it sort of in this statement here. So that means that the area of the person's eardrum is 4 times the area of the bird's eardrum. So the area of the person, that's the eardrum, is equal to 4 times the area of the bird. Okay. Our last step is now thinking that we have power is equal to intensity times the small a times the area. And in this particular case, so we know let's say the power for the bird, if it experiences I times some area, what will the person? So the person receives only 1/4 of that I. So if I say that the bird is experiencing some sort of intensity I, the person is only experiencing 1/4 of that, but the area of the person's eardrum is 4 times larger. So I get the same quantity for the amount of power that's passing through, which is basically the amount of energy that's passing through every second. So having twice the distance reduces for the person, twice the distance from the source, reduces the intensity by a factor of 4, but their eardrum has a twice the radius, which has, with the area of the eardrum, is going to increase the area of the eardrum by a factor of 4. So it ends up being the exact same amount of energy passing through the student's eardrum per second as it is through the sparrow's eardrum per second. So the correct answer is equal to. Okay, I'll wrap that question up there and follow up question 12.